Hi, and welcome to another video. Today, we'll explore a fascinating research paper on AI and its role in career recommendations, focusing on bias, fairness, and human preference. As AI continues to evolve, it's finding its way into critical areas like career recommendations. But one of the biggest challenges AI faces is bias. Essentially, when an AI system picks up on societal biases embedded in the data it's trained on. For instance, if an AI system learns that more men are in certain fields, it may start recommending those careers more frequently to men, even if women are equally qualified. This can lead to reinforcing existing stereotypes and limit opportunities for those who don't fit traditional molds. The goal is to build a system that offers fair recommendations, but as we'll see, it's not as straightforward as simply removing bias. This research focused on career recommendation systems and aimed to debias them. Researchers used a vast dataset from Facebook that contained information on user demographics, interests, and the career paths users eventually pursued. By analyzing this data, they could start understanding how preferences connect with career choices. The key was to create a system that wouldn't allow gender or other biases to unfairly sway career recommendations. The goal was to ensure that the system would offer fair, accurate suggestions that didn't reinforce gender stereotypes, but were instead based on the individual's real potential. The debiasing process aimed to exclude gender as a determining factor in career recommendations. Researchers used an algorithm similar to those found on platforms like Netflix, matching users' interests with those of similar people to make career suggestions. By doing so, they ensured that gender didn't play a role in influencing these recommendations. This figure illustrates the distribution of top career recommendations for both male and female candidates under two different system settings: gender-aware and gender-debiased. In the gender-aware setting, there were noticeable gendered patterns, with certain fields like mechanical engineering and computer science being more commonly recommended for males, and fields like nursing and psychology being more often suggested for females. However, in the gender-debiased setting, these distributions appeared more balanced across genders, indicating a reduction in biased recommendations. The results from this experiment were promising. Not only did the debiased system provide fairer career recommendations, but it also maintained or even improved the system's accuracy in matching candidates to suitable fields. This suggested a fairness-for-free effect, where eliminating bias did not necessarily compromise the system's effectiveness. In fact, it led to more accurate and equitable outcomes in career guidance. Researchers gathered over 200 college students to rate various recommendations. This pie chart shows the gender distribution of participants, with a nearly even split, 49.5% male and 48% female. A smaller percentage identified as non-binary or chose not to disclose their gender. The second pie chart illustrates academic standing among participants. Freshmen made up the largest group at 26%, followed by seniors at 23%, with juniors, sophomores, and graduate students completing the distribution. The third pie chart highlights participants' openness to career suggestions. Here, 82% reported that they had already determined their career paths and were unlikely to change, while only 18% remained open to new career suggestions. This suggests that the majority had clear career goals, which could influence their perceptions of the recommendations provided. Researchers discovered an intriguing result. Even though the recommendation system was designed to be fairer, people showed a preference for the biased system's recommendations. This chart shows the mean acceptance levels for recommendations across three categories: conflict, neutral, and conform. In this context, conflict represents recommendations that go against traditional expectations. Conform represents those that align with expectations. And neutral falls in between. The results indicate that recommendations that align with traditional expectations or are neutral receive higher acceptance scores compared to those that conflict with these expectations. This suggests that users may be more comfortable with recommendations that match traditional norms, even if they're aware of the fairness adjustments in the system. This tendency seems to stem from what researchers call the perceived gender conformity effect, a phenomenon where people are drawn to options that reinforce conventional gender norms. Remarkably, this bias isn't unique to adults. Studies show that even young children exhibit strong stereotypes about careers. These findings suggest that societal biases are deeply embedded and may shape our preferences unconsciously, affecting decision-making even when we aim to be fair. This helps explain why, despite efforts to promote balanced recommendations, traditional gendered patterns in career guidance may still be appealing to users. Given the complexity of human bias, researchers suggest some innovative approaches to improve AI fairness. First, they propose using AI itself to help individuals recognize their own biases. Imagine an AI that can identify subtle biases you might not even realize you have, going beyond traditional surveys and self-assessments. Another critical step is making AI fairness and bias explanations understandable for everyone, not just experts. If people don't understand how an AI reached a recommendation, they're less likely to trust it. By simplifying these explanations, we can increase user trust and acceptance of fairer recommendations. One particularly fascinating solution the researchers suggest is using AI-powered persuasion techniques. Rather than trying to convince someone outright, the AI can offer personalized insights that encourage users to consider roles they may not typically choose due to societal stereotypes. For example, if a woman has skills that align well with engineering, the AI might share success stories of other women in the field, or show her how her abilities match what's needed in that career. The aim is to provide a little extra nudge to help people move beyond biases and make more informed choices based on their true strengths. In redefining fairness in AI, researchers highlight that a balance must be struck between a technically fair system and one that genuinely satisfies user preferences. While it might seem ideal to remove all biases, this research suggests that a bias-free system might not always align with what users actually want. When it comes to career recommendations, fairness should account for human biases and preferences, respecting the complexities of both. Designing AI systems this way requires an understanding of both technical fairness and the human perspective, which is essential for real-world applications. Let's end with a thought-provoking question. Imagine if an AI could perfectly predict your ideal career path, considering your skills, personality, and the job market. Would you follow its suggestion, even if it challenges your ideas about certain roles? This research pushes us to question our assumptions about AI, fairness, and trust. How much should we let AI shape our decisions, especially when it might push us out of our comfort zones? This journey toward creating balanced and fair AI is ongoing, and understanding our biases is a big step toward better design and application of these technologies.
Thanks for watching. I hope you find this video educational and informative. If you like this video, please subscribe to my channel. See you in the next video.